Hey everyone, so today we're going to be talking about evolutionary diagrams, and it says here that diagrams that show how different species are related, how modern species are connected to their common ancestors, and how species have changed over time are called cladograms. Analyze these cladograms to answer the questions. When analyzing cladograms, some things to remember. The youngest time in organisms are on top. The oldest time in organisms are at the bottom. The cross points represent organisms that are common ancestors and organisms that the others after it both evolved from. So, at the top, closer to the top, newer, further away from the top, older. Most recent common ancestor of A, B, and C is before here. Most recent common ancestor of B and C would be here. Alright, so if we look at our first questions, what is the common ancestor of species E and species F? So if we look at E and we look at F, and we trace those back, what do you see? Right, H is the common ancestor for both of those. So what is the common ancestor for species H and B? So if we have H, we know where we got to find B. B is over here, so I'm going to take my finger and my pen, I'm going to trace those back to where they both meet. So where am I at? I'm at R. So it would be R. So go ahead and follow that through for 3, 4, 5, and 6. Alright, so let's look. Which pair had the most recent common ancestor between A and F? So if I look, I'm going to take my finger on A, take my finger on F, and I'm going to trace it back. And you see that it's M, so I'm going to write an M right here. So then for C and D, so I got C here, D here, not too hard to trace that back. You can see that it is G. And then B and D. So B, D, okay, keep going. So I see that they meet at X is their common ancestor. So now that I know the common ancestor of each of these, I have to determine which one is the most recent. So M is at the bottom, so I know that's the oldest. G is up here, above X, so that means that G is newer than X. So that would mean that G is my most recent common ancestor. So species H evolved before species M. Is that true or false? If I look at species H and I look at species M, it says that H evolved before M. But we know this is time and M is at the bottom, so it's the oldest. So H had to come after M, not before. So that's going to be false. Species A is not related to species R. So I have A up here. R over here. Do they share a common ancestor? They do. They share a common ancestor. So that means that they are related. So this is also false. Species M is the common ancestor of all the other species on this diagram. So if I see M, I can trace that to every other organism on this chart. So that means that M would be the common ancestor of all the species on the diagram. So that one would be true. Alright, so then we're going to go down, and we're going to look at the bottom. We have a little bit of a different evolutionary diagram at the bottom. So what species was the common ancestor of all four-legged organisms? So if I look, where do I start having 4 legs? So that's going to be right here at the newt. Got 1, 2, 3, 4. And so what is its common ancestor? I see, trace it back to B. Everything after this has 4 legs, and I can trace it back to B. So B would be the common ancestor of all four-legged organisms. What two are most closely related? Chimp and lizard. So I have the lizard and I have the chimp here. Chimp and newt. So chimp and newt. Or chimp and lamprey. So I have ancestor C, ancestor B, and this one in the middle right here. So because the chimp and the lizard are most closely related, they are literally closer together on the chart. So they share all of these characteristics together, minus this one. This is the one that they do not share together. So that means that the lizard and the chimp are going to be the most closely related. Right? And so that's gone into how we know as well. So because they are closer together on the chart, they're both at the top, more recent, they share these characteristics in common, they're just lacking this characteristic. So that is how we know that they are the most closely related. So we're going to flip to the back. And I'm going to zoom out. So on the back, we have a little bit different diagram of the human evolution. And we have some questions about this diagram. So humans evolved from gorillas. True or false? So if we look at gorilla and we look at humans, they're both coming across up here. And we see that they share a common ancestor here at Y. But they did not evolve from each other. They both evolved separately from that common ancestor. So that's going to be a great big false. Humans and gorillas have a common ancestor. Well, we just said, if we trace it back, they both meet together at Y, so that is true. So now we have the question, evolving from and having a common ancestor. So how is evolving from and having a common ancestor different? And use examples from any of the charts on this sheet. So evolving from would be coming after. So here we see W is evolving from common ancestor X. But here we have these two. So Bombo did not evolve from chimpanzee, but they both evolved from their common ancestor of W. And here on 12 it says the common ancestor of chimpanzees and bombos evolved later than species X. So we have chimpanzees and we have bombo and we have their common ancestor, and it evolved later than species X, which is true, because if we look, species X evolved right around 6 million years ago, and then their common ancestor evolved around 3 million years ago. So that would be true. Species Y evolved about 6 million years ago. True or false? So if we look, here we have the 6 million years ago, and then we have species Y. Species Y is right here along the 8 million years ago, so that's going to be false. Now, in this last question, it says, humans and chimpanzees have some DNA in common. True or false? So if we again look up humans and chimpanzees, we have 48 chromosomes for chimpanzees, and we have 46 chromosomes for humans. And if we trace it back to the common ancestor, their common ancestor is X. So since they're evolving from the common ancestor, they would have DNA in common, just as you would have DNA in common with your grandparents that you evolved from. And again, you can use the information that we said by looking at the chart up above to support your answer for question number 14. Let me know if you have any questions. Have a good day. Bye, guys.